Hi, welcome to Unit 5, Day 7, Types of Chemical Reactions, Combustion Reactions. This is Part 2a, where we'll look at balancing combustion reactions. For today, we have 5 items for our success criteria, and in Part 1, we covered the first 3. So in this video, we're going to learn the strategies for balancing combustion reactions. This has been divided into 2 parts. In this part, we'll go over the strategies, and then in part 2b, we'll do some practice problems to help you review the strategies. So let's start with our first strategy. If you're given a combustion reaction like this, combustion of propane, and you needed to balance it, remember the thing that we always do is we're going to change the coefficients, which are the big numbers in front, until we have the same number of atoms on both sides. So to start off, we would list out the number of atoms we have on both sides of the arrow. So on the reactant side, we have 3 carbons, 8 hydrogens, 2 oxygens. And on the product side, we have 1 carbon, 2 hydrogen, and 3 oxygens. And the reason why we got 3 oxygens, we have 2 from the CO2 and 1 from water. All right, so if I were tackling this problem, the first thing I would want to do is I would want to balance out my carbons and hydrogens first. To get them to be the same on both sides. So I would change the coefficients in front of CO2 and H2O in order for them to be the same. And that should be an 8, by the way, not a 4. All right, I went ahead and corrected that. And the reason why this should be an 8 is because, remember, you multiply the coefficients in the subscript to get the number of atoms. So 4 times that 2 means we have 8 hydrogens there. All right, so now that we have that done, the next thing we would want to do is try and get the oxygens to balance. Now, right now, we have a total of 10 oxygens on the product side. And the reason we have 10 is we have 3 times 2, which gives us 6 from CO2, and plus the 4 times the 1, so 4 from the H2O. So 6 plus the 4 gives us a total of 10. So my next goal is to try and balance the oxygen. And to do that, I would change the coefficient in front of O2. So notice that I balance the oxygen last. Now, why would I want to balance the oxygen last? You may remember from the practice video that oxygen on the product side is found in 2 different molecules, right? So any element that's found in 2 or more molecules on any side of the arrow, you want to balance it last. Notice how carbon is only found in CO2 on the product side and only in C3H8 on the reactant side, and hydrogen is only found in C3H8 on the reactant side and H2O on the product side. You can go ahead and balance them because they're not doubling up on any one side. So this is our balanced chemical equation right here. Remember, there's an invisible 1 in the front, and our key strategy that we just learned is that we're going to balance the oxygen last for combustion reactions. The next thing that we're going to talk about is not really a strategy, it's more like a rule. So coefficients, which are the big numbers in front, must be in the smallest whole number ratios. Let's first start by talking about smallest ratios. What do we mean by that? That means when we say smallest ratios, that means you can't reduce them or simplify them further, meaning they can't have a least common factor. So let's take a look at that. In the balanced chemical equation for the combustion of propane, the coefficients are 1, 5, 3, and 4. They're the smallest ratios because they don't have a least common factor. You can't simplify them further. Now, to make that make sense, let's look at some examples where that's not the case. So let's say you balance the equation, you get the coefficients to be 2, 10, 6, and 8. Now, in terms of the number of atoms being the same on both sides of the arrow, this is true in this equation. You have the same number of carbons, hydrogens, and oxygen on both sides of the arrow. However, the coefficients are not in the smallest ratios because they're all divisible by 2. We can simplify or reduce these coefficients, right, by dividing them all by 2. So this would not be an allowed balanced chemical equation. And then second example, you see the same thing here. So in this case, all of these coefficients, 5, 25, 15, and 20, they're all divisible by 5, meaning you can simplify this or reduce it further to get to 1, 5, 3, and 4. So the first sort of rule here is that the coefficients must be the smallest ratios. If you can divide them by a number, if you can simplify all the coefficients by dividing them all by the same number, then you're going to have to do that and make them the smallest ratios possible. The next thing we mentioned is that they must be whole numbers. So what do we mean by that? Whole numbers means they cannot have decimals. So if you look at these coefficients, they're all whole numbers, right? There are no decimals there, 1, 5, 3, and 4, all whole numbers. But if we look at an example like this, where we have 0.5, 2.5, 1.5, and 2, the 0.5, 2.5, and 1.5 are decimals, so they're not allowed as coefficients. And the reason why that's the case is you can't have a half a molecule of propane, because if you have a half a molecule of propane, it's no longer propane. The same thing for O2, like you can have 2 molecules of O2, but that half molecule of O2 will no longer be O2, it will just be an oxygen atom. So you can't have decimals in your coefficients. And when we go over the practice, we'll see some strategies for how to deal with things when you have decimals. All right, so the main key strategies here are to balance the oxygens last. Make sure that the coefficients are the smallest ratios possible. They can't have a least common factor. You can't simplify them by dividing them all by the same number. And they all must be whole numbers. No decimals are allowed. Now, in the next video, part 2b, what we're going to do is we're going to do some practicing balancing combustion reaction equations. And these are the practice problems we're going to go over. And then you'll have a CFU at the end. So the idea being giving you some sense of how we use these strategies. All right, that's it for this video. Have a quality day.